point is segment. If we draw a diagram, if we draw a chord, listen. This is the R, right? This is the R. This is the chord, right? So the region means the part, region, this one. The region lying between the chord and the arc. The region lying between the chord and the arc is known as the segment of the circle. Is known as the segment of the circle. Are you getting it? The region lying between the chord and the arc of a circle is known as the segment of the circle. Idea lगा कुछ? The region lying between the chord and the arc. एक chord ले लीजिए, chord के पास वाला जितना भी एरिया आएगा arc के अंदर में, that whole area is known as the segment. This is known as the segment. Now again the question arises. Chord का आप ये वाला पोर्शन देख रहे हो, this is also arc, है? It is also arc. Chord के उधर भी तो आपका बनेगा segment, clear? So that is also a segment. This larger portion. Clear? So the smaller portion is known as minor segment, and this one is major segment. Clear? Any doubt anyone? In arc also, the smaller portion was the minor arc and the larger portion was major arc. In segment also, smaller segment will be known as minor segment and larger segment will be known as major segment. Any doubt anyone? Good. So, finding the area of segment, there is also a formula, but I will not tell you it. Okay? You just know about what is segment and what is a minor segment and what is major segment. Yes? The length of the area of that segment will be taught you later. Okay? Segment is clear? We have discussed today arc of the circle and the segment of the circle. Now the next topic will be sector of the circle. Sector. Listen. If this is the center of the circle, then OA and OB are the radius of the circle, correct? These are the radius of the circle. So the region lying between two radius, and the arc of the circle, this arc, na? The region lying between two radius and the arc of the circle is known as the sector of the circle. This portion is the sector of the circle. Okay? This is your sector. The region lies between two radius and the arc of the circle is known as the sector of the circle. Clear? And for the chord, we were saying that for segment, it was the region lying between chord and the arc of the circle. That was the segment. And the sector, the region lying between two radius and the arc of the circle is known as the sector. So again, if this is sector, it is also sector, na? So the smaller portion will be minor sector and larger portion will be major sector. Any doubt, anyone? All clear? So in this portion we have discussed about the circle, its definition, center, radius, circumference, diameter, chord, tangent, secant, arc, segment and sector. These all points we have discussed, right? So basically now you have got all the ideas of a circle, all the basic terms that will be used in this chapter. Clear? So now we will see some important theorems regarding this chapter. Clear? We will see some theorems regarding this chapter. So your first theorem will be, anyone having doubt up to here? In any definition, in any point, in the definition of circle, radius, circumference, chord, diameter, sector, segment, tangent, secant, any definition, do you have any doubt? यहाँ तो जाएगा सारा का ना, इतना टफ नहीं है, just imagine about the circle, है ना, और उसमें क्या था, उसी पॉइंट के बेसिस पे आपका डेफिनेशन सबका फिक्स है ना? अगर आपको माइंड में आ गया सेक्टर की बात हो रही है, द रीजन लाइन बिटवीन टू रेडियस एंड द आर्क ऑफ द सर्कल नोन एज द सेक्टर, है ना? द रीजन लाइन बिटवीन द chord एंड द आर्क ऑफ द सर्कल नोन एज द सेगमेंट, है ना? Secant, tangent, everything is clear now? Clear? So now we will discuss about the first theorem. The first theorem states that in a circle, if two equal chords are drawn, in a circle, if two equal chords are drawn, then they will subtend equal angle at the center. Then they will subtend equal angles at the center. Means it is saying that if this is your circle, let this be a chord and let this be a chord, and it is given that both the chords are equal in length. Let this be AB, this is CD. Yeah? So what is given to you? Given data is AB is equals to CD, and we have got a circle of center O, right? This is our given data, and what do you have to prove? Listen, it is saying that if the length of the chords are equal, then these chords will subtend an equal angle at the center. Means if I join like this, so this angle and this angle we have to prove them equal, है ना? So what we have to prove? We have to prove that angle AOB is equal to angle COD. Clear? This is what we have to prove. This is what we have been given. Now let's do the proving. Proof. What we can do? If we prove both the triangles congruent, then by CPCT we can prove the angle equal. So let's take in triangle AOB and triangle COD. In triangle AOB and triangle COD. What are the things that are equal? OA is equals to OC. What? Radius. Radius of same circle is equal. Correct. OB is equals to OD. It is also radius. And AB is equals to CD. It has been given to you. Clear? Now what? By which criteria? S criteria. Is it clear? Good. So now, by CPCT, angle AOB is equal to angle by CPCT. Is that clear? So this is done. Note it down. Note down fast. Note down it. Done?
Yes.
This was the theorem 1, huh? Now we will discuss about theorem number 2. Theorem number 2. Listen, theorem 2 is the converse of theorem number 1, right? Like if it is saying that in the first theorem it was saying that if two equal chords are drawn in a circle, then they will subtend equal angle at the center. Clear? So if we say vice versa, it means if it is saying that two chords are subtending equal angle at the center. Two chords are subtending equal angles at the center, then they will be equal in length, right? If two chords are subtending equal angle at the center, then they will be equal in length. That is the theorem number 2. Clear? It means if in the same diagram, now the given value will be angle AOB will be equal to angle COD, right? So your given data is angle AOB is equal to angle COD. Clear? And what you have to prove? AB is equal to CD. We have to prove that AB is equals to CD. Clear? Now listen. If you see carefully, proof. Again we will take both the triangles and we will prove them congruent. In triangle AOB and triangle COD. Clear? What we have been given? OA is equals to OC, radius. OB is equal to OD, again radius, and angle AOB is equal to angle COD. It is given. It is given, right? So we can say that triangle AOB congruent triangle COD by this criteria. SAS criteria. Clear? So again we can say that what? AB is equals to by CD. Clear? Let's go down fast. Look it down. Go down fast. Done, na? Go fast.